Hello everyone. Okay, so for the next part, okay, so can you hear me, all of you? Can you hear me? Hello, can you hear me properly?
Yes, sir.
Okay, so for the next part, all of you open your IS 456. Open IS 456 and go to clause number this one. Go to clause number 23. Yeah, go to clause number 23.2. 23.2. Control of deflection. Go to clause number 23.2 for the next part. Okay, so till now, what we have done, we have designed the beam. That means we have find out the dimension of the beam, that is our width of the beam and the depth of the beam, and also we have calculated the area of steel we are going to provide. Okay, we have in this case we are providing this amount of steel, 942 millimeter square of steel, and we are providing three number of bars, and the diameter is 20 millimeter. Okay, and also we are providing 8 mm diameter stirrups. Okay, so the remaining part is for checking. Means whatever beam we have designed till now, in this case we have designed a beam, but we have to check whether our beam is safe for deflection or not, whether we have provided our shear reinforcement or not. We have to check it now. Okay. Okay, so now for this check of deflection, we have to see the clause number 23.2. Okay, so as per this clause, you can see here, okay, you can see here 23.2.1, the deflection limits are given. For different beams, the deflection limits are given. Limits means it is given in terms of a ratio. You can see here, the span to depth ratios are given. The span to depth ratios are given for different kinds of beams. Means if you can see here the basic values of span to effective depth ratios for spans up to 10 meter. Okay, that means if the span of the beam is up to 10 meter, the ratio of your span to effective depth for cantilever beam, it should not be more than 7. For cantilever, for simply supported, it should not be more than 20, and for continuous, it should not be more than 26 to, okay, to check the deflection or to keep your beam safe. Okay. Okay, so now in this case, since our span is only 6 meter, that means we have to use, and the beam is simply supported. Okay, so we will use this value. Okay, we will use this value. Okay, so now let's see how we have to use this value. Okay, so before using this value, first we have to use this curve. There is a curve given as in IS 456. You can see here. This curve we have to use. First, we have to find out this factor, which is our modification factor. Okay. First, we have to find out this modification factor with the help of this curve. Okay. I hope all of you have got this in IS 456. Is it? Can you see the graph in IS 456, or you can see the screen also?
Yes, sir.
Okay. So from this curve, what we have to do, we have to find a factor which is known as modification factor. But first, we have to find out this one, percentage of steel. Okay, percentage of tensile reinforcement. First, we have to find this value. What is the percentage of tension reinforcement we are providing? And also, we have to find out this Fs. This Fs means stress in steel. Okay, so based on these two values, we will use these curves to find out a factor which is known as modification factor. Okay, so first, let's find out what is the percentage of tensile reinforcement. Okay, and the formula is, all of you know the formula, it is 100 AST by BD. Okay, so that is our PT. This thing we have done in the previous chapter also. 100 AST by BD while using table number 20. While using table number 19. Yes, while using table number 19, in case of shear reinforcement, we have calculated the percentage of steel. Okay, here also we have to do the same. PT, it is the percentage of tension reinforcement. 100 AST by BD. Okay, this is your 100 AST divided by B into D. Okay, and these values, all the values are, you can see, we are using the provided values. Okay, not the required values. This 942, it is the provided AST. This 462, it is also the provided. This 250, it is also the provided width. Okay, so whatever values we are using, it is the actual values. That means whatever values we are going to provide in our final beam, that values we have to use here. Okay, 900 AST means AST provided, not the required one. AST provided divided by B into D. Okay, so if you put all the values, we will get percentage of steel is 0.8%. Okay, so next, see how to find out the value of Fs. Fs means stress in steel. So as per IS 456, there is a formula given for Fs. You can see here in this graph. It is 0.58 Fy into AST required divided by AST provided. Okay. So here also we will use the formula 0.58 Fy into AST required divided by AST provided. Okay, so Fy all of you know, because we are using Fe415 grade of steel, so Fy will be 415, 415. AST required, so required is how much? We have calculated before. AST required was 833, and AST provided, how much it is provided? It is 942. So if you use the value, we will, if you put all the values and do the calculation, we will get Fs equal to 212 Newton per millimeter square. Okay, so now we have both the values of Fs and PT, that means percentage of steel as well as stress in steel. Okay, so now with the help of these two values and with the help of the graph given in IS 456, we will find out the value of modification factor. Okay, let's see how to do it. Okay, so now for 200, for Fs equal to 212, we need the value of K. K means our modification factor. Okay, so but in this curve you can see there is no value given for Fs equal to 212. Okay, for Fs equal to 190, one curve is given, and for Fs equal to 240, one curve is given. Okay, but we need the value at 212. Okay, so can you find out the value for Fs 212? Can you tell me how to find out? Without seeing the calculation in the PDF, can anyone do you have any idea how to find out the values? Do you have any idea how to find out the value of K? K means along y-axis, this value we have to find out for Fs equal to 212. So do you have any idea, anyone, how to do it? Raju, Wanchin, Nanu Padung, can anyone tell me how to find out? Just tell me the procedure. Tell me I am not asking you the value. I am just asking you how to do it. Means what procedure you will follow. If you can hear me, please tell me. Okay. If you know, you just tell me. We yes, no, or we don't know. Just reply something. If you can hear my voice, at least respond. Okay. Please respond. Whether you can find out or you cannot find out, just tell me by using Fs formula. Fs formula depends on where Fs intersect with the given line by using Fs formula. By Fs formula, so you cannot find it because Fs formula already we have used this formula to find out the value of Fs, stress in steel. But we don't need the value of Fs now. We already have this. We have Fs equal to 212. But we need the value of this modification factor. When the Fs value will be 212, we need the value of modification factor. Okay, so now you see. Okay, so what is the percentage of tension steel? It is 0.8. Okay, it is 0.8. That means for 0.8, we have to find out this value. We have to find out the value along this line. Are you understanding what I'm trying to say? Our 0.8 percentage of steel is 0.8. Okay, so now for 0.8, this is the line. So along this line, we have to see. Okay, so for Fs equal to 190, you can see this is the point at which it is intersecting. Is it? This is the point at which Fs is intersecting at 0.8. So for this point, what is the value of K? You can find out from here. You can find out from here, corresponding to this point, you can find out some value here, K value. Similarly, for 240 also, this is the point at which it is intersecting. This is the value, this is the point at which it is intersecting. Okay. So for this one also, you will get another value. So it will be, this is 0.8, this is 1, this is 1.2. So it will be around 1.1. You can see here, this value. For this point, at this, okay, this point, if you draw a horizontal line, it will intersect somewhere here. Okay, so it will be around 1 point, it will not be 1.1 exactly, it will be less than that. It will be 1.15 like that. Okay, it will not be exactly 1.1, it will be less than that. So it will be 1.05 or something like that. Okay, and for this point, you will get another value here. It will be around 1.3 or 1.35, something like that. Okay, if you use your scale, okay, then only you can find out the value properly. Okay, so now we have two values. For Fs equal to 190, K value is 1.335, and for Fs equal to 240, K value is around 1.1. Okay, and we need the value at 212. So what is the procedure we have to follow? Can anyone tell me the name of the procedure? If you have two values given and we need the value between, we need a value between those two values, then what procedure we should follow? In mathematics, this procedure is known as it is also mentioned in the PDF, interpolating. That means the procedure is known as interpolation. If two values are given and we need a value between those two values, then the procedure whatever we will follow, that is known as interpolation. Okay, so you can see here for Fs equal to 190 it is 1.35, and for Fs equal to 240 it is 1.2. Okay, so now we need the value at Fs equal to 212. We don't need this value, we don't need this value, but we need a value between 190 and 240, that is our 212. So there is a simple calculation and the method is known as interpolation. Okay, so if you use the calculation, we will get the modification factor 1.29. Okay, we will get the modification factor value as 1.29. Okay, so now after getting the value of this modification factor, what we have to find out? We have to first find out what is the maximum value of L by D. L means your effective span divided by your effective depth, maximum value. Okay, so as per IS 456, L by D value is, maximum value of L by D is 20. Okay, but we have to multiply the multiply the maximum value with the modification factor to get the required value of L by D maximum. Okay, so L by D max is, as per IS456, it is 20, and we have to multiply the value by the modification factor, which is 1.29. So if you multiply the value, you will get 25.8. Okay, then we have to find out what is the provided value, L by D provided. L is 6000, effective span is 6000. D provided is your 462. So if you do the calculation, you will get 12.9. That means our provided L by D value is less than the maximum value. That means our design is correct. Okay, our design is correct and our beam is safe for deflection. Okay, this is a simple one. After finding out, in this step, only one thing is there. You have to find out the value of modification factor from the graph. Okay, modification factor from the graph. So after getting the value of K, first we have to find out L by D max, then we have to find out L by D provided. If our L by D provided is less than the maximum value, that means our beam is safe for deflection. And if L by D provided is more than the maximum value, then we have to redesign the beam. Okay, we have to redesign the beam. Okay, so now if you have any doubt in this part, you can ask me. Control of deflection, if you have any doubt, you can ask me. If anyone have any doubt in control of deflection, you can ask me now. Okay, so I hope all of you have understood this part. Okay, so after doing the deflection, we have to design for shear. And this part I'm not going to explain because we have, in the previous chapter, we have solved so many numericals on this. So I'm not going to explain this part, design of shear. How to design the shear reinforcement, I'm not going to explain again. Okay, you just go through it. Okay, so after designing the shear reinforcement, okay, so no need to check for development length. Okay, so finally you have to write down the design summary. Okay, so in the design summary, you have to write down the dimension of the beam. You have to write down the reinforcement which you are going to provide. Okay, you can see here, main tension bars are 3 numbers of 20 mm diameter bars of Fe15 group. Okay, and then you have to write down the shear straps. That means shear reinforcement. In this case, we are providing 8 mm diameter, two-legged, and the spacing between them is 300 millimeter center to center. Okay, next. Okay, so can anyone tell me what is this anchor bars? Anyone have any idea about this anchor bars? Do you have any idea about anchor bars? Can anyone tell me what is anchor bars? Raju, Wanchin, Nanupadung, hooks and bends. Hooks and bends. Anyone have any other answer? Anchor bars? One chain? Support करने दिया बार. Yes, good. Additional support. Yes. Support करने दिया बार. Yes, good. For supporting those stirrups. Okay, for supporting the stirrups, we have to provide anchor bars. Otherwise, since it is a singly reinforced beam, our main reinforcement will be only in the tension zone. Okay, but we have to provide our stirrups. So if you don't provide any bars at the top, then you cannot bind those stirrups. Okay, so we will provide some extra bars, which is known as anchor bars, to support those stirrups, and also it will provide some amount of resistance. Okay, that means it will provide it will take some amount of compressive stress, and it is provided only for mainly for additional support. Yes, support करने के लिए दिया हुआ है. Good. Additional support for stirrups. Okay, so this is the design summary of the problem. I hope all of you have understood this problem, and then also if you have any doubt you can always ask me. Okay, so now do you have any doubt in this problem? Anyone have any doubt in any step in this problem? Anyone have any doubt in this problem? Anyone have any doubt in this problem?
Sir, what is that shear stirrup?
Shear stirrups means stirrups. I have skipped this step, na? Design of shear reinforcement, because this part has been solved in the previous chapter. Design of shear reinforcement. Shear stirrups means we are providing the shear reinforcement. Na? In any beam, we have to provide the stirrups. So this part I have skipped here because this part has been solved. This part has been discussed so many times in the previous chapter. Okay, so shear stirrups means shear reinforcement, or just we say it is the stirrups. So this is the procedure. First we have to find out nominal shear stress, then we have to find out the shear strength, then we have to compare the values. Okay, then we have to find out VUS, shear to be carried, then we have to find out the spacing. Okay, we have to find out the spacing of the stirrups. Okay, this part I have skipped because this part has been solved so many times in the previous chapter. Okay, you can see here, provide 8 mm 2 leg bars at the rate 300 mm center to center, and two number of bars as anchor bars in the compression zone. Okay, so any other doubt? Anyone have any other doubt?
Sir, K value to आपको एक बार repeat कर दो.
K value to modification factor. है ना modification factor राजू? Modification factor नहीं है राजू. Okay, so now for a beam, first for finding out this K value, that means our modification factor, first we have to find out the percentage of steel. So it is 100 AST by BED. Okay, formula is 100 AST by BD. So in this case, we have got PT, that is our percentage of steel is 0.8%. And FS means stress in steel. The formula is given in IS 456, 0.58, 0.58 FY AST required divided by AST provided. So after putting all the values, we have got the value of FS as 212. Okay, but now if you go through the graph, if you see the graph, there is no value corresponding, there is no curve for Fs equal to 212. Okay, so now what we have to do, we have to interpolate. Okay, because we have a graph for Fs equal to 190 and we have a graph for Fs equal to 240. We have two graphs. Okay, but we need a value between these two Fs values. We need a curve between these two curves. Okay, but we cannot draw we cannot draw an imaginary graph here, and we cannot find out the value. Okay, so for that, what we will do, we will use the simple mathematics, which is, and the procedure is known as interpolation. Okay, so first we will find out for fs equal to 190 what is the value of k. Okay, for fs equal to 190, this is the curve for fs equal to 190. This is the curve for fs equal to 190. Okay, fs equal to 190, and our percentage of steel is 0.8. Okay, so we have to see along this line. Okay, we have to consider only this line. So at 0.8%, when the value of fs equal to 190, you can see the value here. This is the point. So at this point, what is the value of k we will get from this y-axis? Okay, so fs equal to 190, at fs equal to 190, the value of k is around 1.3 or 1.35. Okay, so next for fs equal to 240, this is the curve, fs equal to 240. Similarly, for fs equal to 240 at 0.8%, what is the value here? You can see this point. This is the point at which we need the value of k. Okay, so at this point, the value of k will be around 1.1 or 1.15. It will not be 1.2. Okay, it will be around 1.15 or 1.1. It will be more, it will be around 1.1, because at this point, if you draw a horizontal line, you will get a point here. It will be around 1.1. Okay, so now we have two values. For fs equal to 190, we have a value of k, and for fs equal to 240, we have a value of k. Okay, but now we need a value at fs equal to 212. Okay, you can see the procedure here. For fs equal to 190, k value is 1.35, and for fs equal to 240, k value is 1.2. Okay, so now we need the value at fs equal to 212. Okay, so this is the procedure by which we can find out the value of k. This procedure is known as interpolation. So if you put all the values, then you will get kt equal to 1.29. Okay, 1.29 at fs equal to 212. So the remaining procedure is very simple. After getting the value of k, the remaining part is very simple. Okay. Okay, so now I have a assignment. I have an assignment for all of you. Okay, so now I am going to give you the question. I will give you the question. All of you have to submit. Today is 11th. Okay, so on 17th. Yeah. On 17th, all of you must submit that assignment. Okay. All of you must submit the assignment on or before 17th, not 18th. Okay, so after 17th, I will not accept anyone's assignment. I will give you only one question. I will give you only one question. So all of you must write. Okay, all of you must write with pen. All of you must write with your pen, with your own handwriting. Okay, and then you have to take photo and you have to make a PDF, and then you have to send it in my mail. Okay. Okay, so now I'm going to share the question with you. All of you must solve that question, and you have to submit by 17. That means that next Wednesday. Yeah, by next Wednesday, all of you have to submit that question. Okay. Okay, it was the question from. This question has been asked in 2016. Yeah. This question you have to solve it by limit state method. Okay, not working stress method. In 2016, this question was asked for working stress method. Now I am giving you this question. All of you must solve this question by limit state method. Okay, and the last date is 17th. By 17th of November, all of you must submit this question to me. Okay, after 17th, I will not accept anyone's assignment. Okay, last date of submission is 17th. So after 17th, I'm not going to accept the assignment. And all of you must write the answer with your pen, in A4 sheets, and you have to take photo, then you have to make a PDF, and then you have to send the file. Okay. And in that assignment, you have to write down your name, enrollment number properly your enrollment number. Okay. Enrollment number, name, then your section, and the subject name. Okay. Okay, so can you, all of you, I think all of you can see the screen? Yes? I hope all of you can see the screen. And this is the question. Okay, this is the question. Question number 6. This question, you write it down. All of you write down the question. By limit state method. By limit state method. That means by using IS 456. By limit state method, you have to design this beam. I am giving you only one question, but I am giving you 6 days. Okay. Okay, and email ID, you have to, instead of sending individually, what you have to do, you will make a file of 10 students in a single file. Okay. You have to compress it and you have to make a zip file for 10 students and then you have to send it. Otherwise, if 70 students will send me 70 emails, it will be very hard for me. It will be very time consuming. Okay. Instead, every 10 student will make a file. File means it will be a zip file. I hope all of you know what is zip file. In that zip file, if I open it, I can see all the files. Say 10 students will be there, 10 PDFs will be there. Okay, 10 PDFs will be there. So you make a zip file for every 10 students and then you send me in my email ID. Personally, if you send me your PDF, I will not see that PDF, but you send the PDF for 10 students together in a single file. Okay. So I am going to share the email ID, my email ID. Okay. For every 10 student, I must receive one zip file. Okay. For every 10 student, I must receive one zip file. And all of you must write with your own handwriting. Okay. Your handwriting should not match with each other. If I can see anyone handwriting, if 2 students are handwriting are same, both the students will get 0 mark. Okay, and I will give a separate assignment for them. If I can find 2 or 3 students having the same handwriting, then I will not accept their assignment and I will give those students a separate assignment. Okay. Okay, so I hope all of you have written down the question. So this is all about today's class. Okay. So thank you, and I hope all of you can submit the assignment by 17th. Okay. So thank you everyone.